Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to go over the legendary hot bus main service panel, how it pertains to the National Electric Code when connecting solar and energy storage to your electrical service. Let's get into it. So first, what is a hot bus panel? A hot bus panel is a main service panel that does not have a main breaker coming in from the utility. Essentially, it has two bus bars that come in on each leg, as you see here on the bottom right, that are just always hot coming in from the utility. Those are your service conductors, and it just has a hot bus in the middle there that is built to contain up to 6 double pole circuit breakers. Each one of those circuit breakers are considered to be a service disconnect. So you can have up to 6 service disconnects in a hot bus panel by code. You'll see in this panel, you've got a bunch of single pole breakers and quadplex breakers. So this is a code violation. It would not pass inspection, and that's because it has over 6 service disconnects in this panel. Essentially, you have to be able to de-energize the entire service with no more than 6 throws of a handle per the National Electric Code. So you don't really see these nowadays too often. They've pretty much been phased out. Nowadays, you mainly have a main breaker, and that's because of new code rules that sort of require that an electrician be able to de-energize the equipment they're working on. So for example, in most panels, you can de-energize the main breaker. You've got a little protective cover that covers up the hot lugs coming into that main breaker, and then there's nothing energized in the panel, so you can go in and work in there pretty safely without the threat of electrocution. Now that is not the case with these old hot bus panels. They're just always hot. The only way to kill power to this panel is one, either to cut the tag on the meter and yank it out of the meter socket, breaking that connection between the utility and the service equipment, or two, having the utility come out and drop power at the transformer so that you can go in and work on this equipment. So as a hot bus panel pertains to solar and storage, connecting a breaker on this panel, a lot of people get mixed up. You know, they think of a backfed breaker. They'll see that, hey, this is a 200 amp panel. I'm trying to connect a backfed breaker, and they'll go to that backfed breaker rule thinking they're limited to a 40 amp backfed breaker, but that couldn't be further from the truth. In this case, this is a hot bus panel. Any backfed breaker connected to that bus bar is a supply side connection per the National Electric Code. It is on the supply side of all the other service disconnecting means. So, you know, say you had 5 double pole breakers in there, you slapped in a 6th double pole breaker, which is your PV backfed breaker. That breaker is on the supply side of all the service disconnects out there, and therefore it's a supply side connection. And per the National Electric Code, supply side connections, you can connect basically as much solar or battery as you want up into the rating of the service. So technically, you could connect up to 200 amps worth of solar and battery backfeed to this panel. But in this case, we are limited by the equipment here. You'll see over here on the left that every panel has a max circuit breaker, branch breaker rating. This one specifically has a max circuit breaker of 100 amps. You'll oftentimes see 125 amps, things of that nature. So in this case, you know, there's just no larger breaker than 100 amps that you can connect to this panel. So you're just limited by the equipment up to 100 amps of backfeed. Now, when it comes to solar and storage, if you're backing up home loads downstream of the equipment, that also kind of runs you into this issue of, well, you only can connect a 100 amp breaker to feed your microgrid interconnect device or your transfer switch. And therefore, if this is a 200 amp panel, you can't actually back up the entire home downstream of a 100 amp breaker. So, you know, if you had a meter collar, such as the Tesla backup switch or the in-phase meter collar. Franklin's about to come out with a meter collar, and I believe EG4 is as well. That can kind of eliminate these issues where you just, have a meter collar installed right behind the utility meter, and it severs that connection upstream of this bus bar during an outage. But if you're not using that and you're using a traditional transfer switch or microgrid interconnect device, you kind of be stuck with partial home backup in this scenario. So you'd have a 100 amp breaker, feed your MID, that would feed your backup loads, and then you'd have to leave a handful of large loads out here in the main service panel if the combination of those loads using a load calculation exceeded 100 amps. Well, I hope everyone got value out of today's content. Hit the like button, subscribe, press that notification bell. As always, I really appreciate each and every one of you. Till next time, take care.